Okay, we're talking today about variables and expressions. We're on page 16. You should have your math notebooks out. You have this heading on the next section of your notes. I want to talk a little bit about algebra real quickly. How many of you, when we started throwing letters into your problems, you started hating math to a higher degree? You just didn't like it, right? They throw A and X and Y. Okay, how many of you are not fans of the variables? You're not fans of them. Okay, so some of you, actually a lot of you seem to be okay with it. That's good. Why do they throw variables? Why do we use those letters in math? Because I was okay with numbers and adding and dividing those numbers, but now they throw in these variables. Well, we need to understand what a variable is. So let's get a definition. A variable is a letter, usually a letter, that stands for a number or that represents a number. Okay, a letter that represents a number. Mr. A, why didn't they just use a number then? Why do they have to say it's a letter that represents a number? When you get into algebra, a lot of people think, oh no, we're in pre-algebra and then next year algebra and then we start getting into higher math. Do you realize that algebra makes math easier? Okay, easier. And a lot of you are thinking, Mr. A, you're wrong. It makes it harder. Well, it's harder to understand at first, but then the uses of algebra are making things and making life easier for us, okay? Let me give an example. Look on the top of page 16. Do you guys see where it says application medicine? Okay, I'm just going to read some of these facts, and then I'm going to read the bottom paragraph of that section. All right, how much do you know about your hard-working heart? Heart, by the way, I mean, it's working all the time. It's amazing how that muscle just keeps going. An adult heart is about the size of a clenched fist. So this is the size of my heart. This fist, that's my heart. In 1 year, a human heart beats over 30 million times. The heart of a 70-year-old has beaten over 2.5 billion times. Does anyone know anyone who's 70? Maybe like grandparent? Okay, or just somebody maybe at church or someone you know. 2.5 billion times. That's a lot. That's a lot. It's like flexing your muscle, all the time. You don't do that. But that heart is constantly contracting. And then, in an average lifetime, the heart pumps 1 million, this is kind of, for those who are squeamish, 1 million barrels of blood. Okay, that's a lot. Okay? Your heart is doing a ton, and that's why it's so important to take care of your heart and your diet and your activity level. But look at the bottom paragraph. I'm going to skip that middle one. As people age, their blood pressure rises. You've heard of, does anyone have like maybe family members who are kind of iffy with their blood pressure? Or do you realize that that might mean that you might struggle with it? So it's good to know. You can approximate a person's normal systolic pressure by dividing his or her age by 2 and then adding 110. Okay, so what we're going to do with that last statement is I can estimate what our systolic pressure should be, like a healthy one, just by giving an age. Okay? So Mr. A is going to reveal his age. Some of you probably know, maybe know. I asked my 6th graders 3 years ago how old I was. And they're raising their hands. They're wanting to guess here. And I remember, I'll never forget now, a student raised his hand. And I'm like, okay, what do you think? 48! I was it 2 years ago, 3 years old? I was 27 at the time. He said 48. So I walked out of the classroom, shed a few tears, went to the bathroom, washed off, came back in, and I couldn't look at him for the day. No, not 48. So today, I am 30. Okay, I'm 30 years old. Hit the big 3-0 not too long ago. Okay, if you want to find out what my systolic blood pressure is, you take my age, you divide it by 2, and then you add 110. Okay, that's how you get my blood pressure. All right, so let's work this out. Order of operation style, what do we do first? And what do we get? 15, and then we add, sorry about that, we add that 110 and we get? 125. Okay, 125. That's my normal systolic blood pressure. Okay, that's me. Okay, I'm a 30-year-old. All right, someone want to share their age? Marissa? 12. All right, so I'm going to do this now. Marissa can approximate her blood pressure. And who else is 12? Raise your hand if you're 12. Okay, so the 12-year-olds. You do 12. What do you do with that number? You divide it by 2, and then you add 110. Okay. All right, so what's 12 divided by 2? 6. And then add 110. 116 for you 12-year-olds. Okay, so notice mine is higher. Okay. Anyone 13? Okay, anyone 11? Okay, because there might be some younger ones. But all right, 13-year-olds. Any 14? Okay. Whoa, look at you guys, ready to drive, which means I have to get off the roads by a year for some. No. All right, so we have our normal rates. Okay. Your parents, let's say, I don't know, I'm going to guess 40. Don't say if it's true or not. Don't say if it's true or not. Don't say, oh, my parents. All right, let's go with 40. 40 divided by 2, added with 110. Do you guys see any patterns here? How do you find a person's systolic blood pressure? What do? How do you generalize that rule? Give it to me in words. All right, Jensen?
Half their age plus 110.
Okay, you get their age divided by 2, or half their age, and add 110. All right. I can show you every single scenario. I can show you, all right, a 10-year-old, an 11-year-old, a 12-year-old, a 13-year-old, a 14-year-old, a 15, all the way to the oldest living person, which, anyone know?
It's me. Like 113 or 13?
It's I think it's 1 and then something in the teens. Okay, and we can go all the way down the list. I have a chart, and I point out all of them. But isn't there an easier way to write that? There is, and that's where algebra and variables help. Okay, instead of putting all those numbers and all the different possibilities, I'm going to do it in one simple statement. You want to give it to me?
Is it like n divided by 2 plus 1 and 2?
Yeah, and we can use n. I'm going to use a, and I'll tell you why. A divided by 2 plus 110. And then I'm going to say that A represents age. That's it. Done. So now it doesn't matter who you're talking about. What's their age? 56. Fine. Put it in there. Figure it out. That's it. You're done. I don't have to look through this chart. Okay, 1, 2, 3, 4. Look for the 50s. Look for 56. All right, found it. Boom. No, all you have to do now is put in the age, and now you have an expression here. This is called an expression. And this expression covers anybody out there. Everybody. One expression. Right? So let me ask you this. Is a chart of 114 ages or this easier to look at? This right here. This right here is a lot easier. Okay? This is called an algebraic expression. So let's start this up. This is another term, algebraic expression. Okay, and I'll give you a definition. The word algebraic, scary word for a lot of people, but you're not scared of it because you've already dealt with this stuff. This is not new. This is actually going to be review. All right, algebraic expression is a combination, and I'll get out of the way in just a moment, is a combination of variables. And what's a variable again? Anybody remember what's a variable? Yes, sir?
A letter that represents a number.
It's just a letter represents a number. Numbers. Have you ever heard of numbers or seen numbers before? Yeah, we've dealt with those already. You've dealt with variables, numbers, and at least one operation. Okay. At least one operation. What are we talking about when we refer to operation, Tristan?
Like multiplication, division, addition, subtraction.
Yeah, the main four ones, addition, subtraction, multiplication, division, it has to have at least one of these operations. So could it have more? Yes. Okay, ready guys? Let's evaluate. Is this really an algebraic expression? So what I'll do is I'll kind of scroll down. Okay, is that an algebraic expression? Well, let me ask you this. Does it have variables or a variable? Does it have numbers or number? Okay, does it have an operation, at least one?
Yes.
Okay, this is an algebraic expression. Okay, so it meets that criteria. And it's a combination of it. That's it. That's algebraic expressions. Get comfortable with these guys, because guess what? This is the rest of the year. This right here. Dealing with it. Oh, no letters. Why not just numbers? Because we want to make math easier. Well, hard, not harder, easier. Yes, it takes us time to adjust, but really, it makes things easier. Okay, anyone else need this? We're good? Okay, let's look at example number 1. Let's see how we can use this to benefit. This is the actual math you're going to be doing. Example 1. It gives us the expression m plus m minus 34. So I'm on page 17. You guys see example 1? All right, it says evaluate n plus m minus 34 if n is 18. So n is 18 and m is 49. Have you guys ever done these before?
Yes.
Okay, so is this new? This is algebra. So have you already done algebra? Yeah, don't worry about it, guys. We'll take it one step at a time. In fact, there are a lot of things, even the hard things that we're going to look at this year, that I can point back, oh, you've done this in 5th grade. You did it already. You're like, really? Yes. So don't be afraid. Okay, so in this problem, what I want to do is I want to substitute 18 for n and 49 for m, right? Okay, so I'm going to do that. 18's for n and 49's for m. Oh, that's a subtraction sign. Sorry about that. Okay, what do I do first here? Yes, sir. Add. Left to right. Good. In this case, you're going to do that. 18 plus 49?
67?
67. And then minus 34. Sorry about that. 33. That's my answer. Have you already done these problems here? Yeah, those are last Friday's homework, order of operations. And really, these are the basic ones, not even with parentheses and all that. Okay, that's example 1. Okay, little note here. I'm going to bring this up even more. All right, listen up. Why was I able to put 18 here and 49 there? Why was I able to do that? Give me help here, because did it just pop up with those numbers? All right, Michael? What did they tell me in the book, though? Because okay, didn't it tell me that n equals 18 and m equals 49? Okay, what are these called again? Variables, right? And what do they stand for? Numbers. In this case, they gave you what they stand for. So this is a key word right here. I substituted. Okay, do you know a substitute teacher? Okay, a substitute teacher, if you ever have one in this class, is going to be a teacher who stands in my place and is me for the day. Don't call him Mr. A, by the way. That might not work out. But they stand for me. They're going to be the math teacher for that day. Okay? In this case, I'm going to represent 18 here and 49 there. You substitute, okay? I'm trying to drill that word in, substituted, okay, or substitute. All right, let's look at another example. These are too easy, right? Yes. Okay. Actually, before we go, substitution, here's a little note on multiplication. So write this one down. Multiplication. If you memorize your facts, by the way, multiplication is going to be your favorite operation. It's going to be your favorite one. And you're going to be quick at it. So how many of you, I'm asking an honest question here. You don't have to, don't try to deceive me. Just be honest. How many of you practiced the ones you did not know since you took that drill test on, what was it, Tuesday? Monday or Tuesday? Anybody? Okay. Hey, you still have time because you're going to get multiplication. I hope you're ready for it. And I'll try to help you out that throughout the day or throughout the year. Okay, multiplication in algebra. Multiplication's shown a little bit differently. All right, this is an expression. This is called, we name this 3D. Okay, 3D. What does that mean? What does 3D mean? It means 3 times D. Okay, have you ever seen? Okay, that means multiplication. Do they have a multiplication sign here? No. When you have a number in front of a variable with nothing in between, it means multiplication. All right, XY. What does that mean? I'll use these quotation marks to represent means. What does XY mean? It just means X times Y. I like that because it just saves us a step. We can take away the multiplication sign, just write XY. All right? 7ST. What does that mean? Yep. 7 times S times T. Okay? You guys get multiplication? How we're going to see it? So if you see something like 7E, you're like, 7E? I've never heard of that number. Well, it's 7 times E. Okay. And then with division, you might see expressions that's a Q over 4. Okay, what does that look like right now? What kind of number does that look like? A fraction, which also means, so fractions also mean what operation? Yes, ma'am. Division. So this means Q divided by 4. Okay, Q divided by 4. Everyone okay with these? Nothing too hard. It's like reading a key to a like a puzzle or a game. If you don't read the instructions, go look on that game. Anyone like Settlers of Catan? Anyone know what Settlers of Catan? Oh wow, I love it. I love it, Michael. Bonus point for you. Oh, there's trade. Yeah, there are other versions of that. So basically, it's a strategy board game. If you don't read the instructions, you're going to be sitting there rolling the dice, and people are going to be doing this and that, and you're just sitting there, go fish, and you're not going to do very well in that game. So you got to read the instructions, read the key, then you know what's going on. All right, let's look at example number 2, and let's see how this plays out. Example 2 is still on page 17, and can someone read to me what example 2 says to do? What are the bold type instructions right across? Tristan.
Evaluate each expression if x equals 3, y equals 8, and d equals 5.
Okay, and do you guys see how there's A, B, and C? We're going to do all 3 of those. So A, they give us this expression, 7x minus 4z. Okay, 7x minus 4z. So is that algebraic? Is that an algebraic expression? Yeah, it has numbers, variables, and it has at least one operation. How many operations are going on here, though?
3.
Okay, which ones?
7
Brady.
times x.
Okay.
And then 4 times z.
Good.
And then the answers of those minus.
Good, Brady. Very good. So you have multiplication here, here, and then subtraction between those two products. Good. All right. So what I'm going to do is this. Instead of x and z, what should I substitute? So what's x according to that? According to those that example, excuse me. Bella? X is 3. And what is z? Michael? What's z? Oh, sorry. 5. All right, everyone good on those? Okay, notice what I did here. Instead of putting x, I put 3. I put it in parentheses. Why would I do that? Why wouldn't I just put 7, 3, and then minus 4, 5? Marissa? Oh, okay. So you got to show me that it's multiplying here and here. Keep it straight. Okay? All right. What do I do here? Order of operations. Elizabeth.
You multiply 7 times 3.
Mm-hmm.
And you get 21.
Mm-hmm.
And then you multiply 4 times 5.
Uh-huh.
And you get 20.
Good.
And then you subtract 21
Oh, how nice. 1. Okay? Did I show my steps? Did I show the substitution? Am I good? Okay. Let me give you a little. I was working out your homework problems again, and I got to one problem. I don't know which one it was, and I got it wrong. I looked back. I was like, "What happened?" You know what happened? This is, for example, what I did. I put, instead of 5, I put a 6. Then I got something else. Then I got something else. I looked at my answer. Nope, that wasn't it. Oops, I did that. Change that. Changes that. Gets it right. When you get something wrong, that's okay. What you do is check. If my work is shown, what did I mess up? Did I write another one? I forgot to put I put plus instead of minus. Does that happen? And so oops, change, boom, got it. Learn from those mistakes, okay? That's okay if you mess up. Are you allowed to look at the odds for your, to check your work? Yeah, do it. You don't have to hide it from me. Again, some people are like, while they're doing their homework, they're like looking back there, giving me that awkward look. And I'm like, it's okay as long as you're using it well. If you're just looking at it, oh, what's 21? Okay, that's the answer. Good. And you just write it in, then you should be afraid. You should be worried because that is cheating. All right. B, yz over 4. So B is yz over 4. What does that bar mean again? Division. Okay, so you can think of it yz divided by 4. That's totally okay. All right, what does y equal in this problem? 8. What does z equal? 5. And 4 is on the bottom. Okay, so these are equivalent. That means they're the same value. All right, what do I do first here? Let's see. I know Braden and John know. All right, Callie? Okay, what do you get? So I multiply these two together, and I get 40 over 4, and then what do I get finally? 10. That's my answer. Not too hard, guys. What's going to really get you is if you're going too fast, you don't write the correct operation, or you write the incorrect number, that throws you off. That'll throw anybody off. All right, C, last one on this example. Oh, is this it? 3x plus parentheses z plus 2y minus 12. Uh-oh. I'm sorry, now they're getting personal. Now they're getting tougher. Okay, so let's take it one step at a time. All right, this is what I do for myself to help me to keep all the operations straight. Instead of x, what's the value for x? What's the substituted value? 3? Okay, so you see how I did that? No problem there. Pretty basic. All right, watch what I'm going to do here on this set of parentheses. All right, what did I just do there? Oh, I did something. I changed things up. So try to look, what did I do from here to here? Sophie? There were no brackets in the original problem. What's my problem for doing that? Okay, watch this. Remember I said with the variables, I usually put parentheses? So what did I do with those brackets then? Yeah.
Because you can't put the parentheses around the parentheses. You have to put the brackets instead.
Okay, good. I would say you can. It just gets really confusing when you have like double sets of parentheses next to each other and one parenthesis here and then double sets there. Okay, but do you see now working this problem out, I would have to do what's in here. And then I would add it and subtract it with that. So what's z in this problem? 5. What's y? 8. Okay, before I even work this out, is everything written down correctly? Yes. Okay, so what would I do first? Hint, hint, I just told you. Caroline, what would I do first? Yeah, in the brackets, symbols of inclusion, I do what's in here first. So what would I do in here first?
You would multiply.
Yeah, I got my 16 here, so watch what I'm going to do here. And I'm going to drop that parenthesis, and then what's 2 times 8? All right. Oh no, Mr. A, you just wrote everything out. What a waste. What a waste of red digital marker. Okay, that's okay. Get used to it. We're trying to get that funnel going. But Mr. A, we actually use lead and we want to conserve lead. Why? I want to conserve paper. No, you won't. Because if you use that paper partly or completely, you still use one sheet of paper. All right, what do I do next? Ready?
2, 5 plus 16.
All right. And what do I get? 5 plus 16 is what? 21. Oh, sorry. I heard something else. All right, then what would I do? Yes, ma'am? Bill? Okay, I get 9 plus 21 minus 12. Then what do I do?
Left to right.
Left to right, do what?
Addition.
Okay, in this case, addition. And so I get my 30 minus the 12. Combined, give me 18. What a satisfying feeling. When you have this long problem, you do all the substitution, you work it out, and you get a correct answer. By the way, I looked at some of your papers just glancing through on this assignment that you turned in today, which is order of operations, review, right? And I saw, oh my goodness, that looks so beautiful. It looks beautiful. It's clearly showing each step. It's so neat that anyone could read what it says. That's ideal homework. That's excellence board material. Okay? If you struggle with writing too fast or sloppy, or excuse me, if you write too sloppy or you just really struggle with that, some of you, it's going to take just writing a little bit slower. Okay? Just write a little bit slower. Make it super clear for everyone. And even here with Mr. A's distorted board, I try to make it slow so that I can make it legible even on a board that's hard. That changes my writing. I have to adjust to it. Okay, any questions so far? Okay, what we're going to do now is go to page 18, and we're going to finish up the last portion of this lesson. Okay, in algebra and in math in general, you're going to get word problems. Okay, get that sigh out. Ah, okay, good. You got it out. You got to know some key words. And these word problems are actually not too bad. They're not even sentences. They're phrases. They don't even have a period on them. They're just a phrase. But do you guys see that green box with addition, subtraction, multiplication, division on the top of page 18? Okay, those are the key words for those operations. So let me just give you a hint on how to do some of these problems on homework. Look at number 11 on page 19. Do you see number 11 across the page? So I'm on page 18 and 19. Okay, so number 11. Translate each phrase into an algebraic expression. Okay, so it's verbal phrase. I want to change it to algebraic, an algebraic expression. Do I have the door? All right, hold on, guys. Man, this class goes too fast. I wish I had like at least another 30 minutes. All right, this is what I want you to do. I'm going to change the homework to what it was on Sycamore. So you guys should do number 16 to 38. That's it. 16 to 27. 16 to 27. I'm dropping it. Don't tell the other class. Do you understand?
Yes.
They come in and say, yes, we only have to do. We find out who that is. We start talking. So 16 to 27, and that's going to be on page 19. So I changed the homework. I'll change it on Sycamore. Oh, there's just so much to talk about, and we're going to end